Hello everyone, this is Vahid Kutarar, research fellow from University of York, working on a project entitled Reach. And now I'm going to show you some configurations of the scenario that I'm going to test it and simulate it through Tera VM RSG via VRIC tester. We have three different 5G new radio cells with these features, as you can see, and it's a TDD. And we have three main slices here: MIOT, URLLC, and EMBB with different features each. And the slices and this percentage ratio has been done based on the cost functions and allocating the bandwidth percentage to each slice as a number of the user equipments and also its required bandwidths. It's based on the cost function that's given here. We use different number of the users and also different number of the slices. Here we have the three different slices we considered, and we are going to divide the bandwidths and PRBs among them using this cost function. This is a paper that it has not been submitted, but this is based on the thesis of mine during my PhD at University of Bologna in Italy. And now I'm going to show you the main xApps as well. So here bringing the xApps now. Here, network slicing, xApps. And now we are going to see that how it works, this xApps. Stop the test and starting running the test. We have three different slices here, and it has been allocated to the all three type of the slices based on this cost function. This xApp controls. Now we are going to run it. And as it could be seen, it controls the massive MIMO order and cell throughput, and these are the dynamic report for power usage and power consumptions, and power consumption and power saving percentage. And here let's go and see. As we can see, it has been dropped, so that's why the throughput is lower. And now we will go to see the cell throughputs for different slices. Now it's in the highest order. It should be rising in its highest order, and it's working. Now it's in the 88R, so it's going to be decreased here. And now I'm going to show you a network slices that's as it has been targeted, and it varies with the different when the load changes as a function of the load, and we are within the target for each slice. We have considered these 3 slices. We can have more slices generated, but for this scenario we don't need. And this is a cell throughput as a function of the changing cell loads, and these are its controls by massive MIMO order or through the autonomous here. As we can see here, for example, this is a 32T 32R and its results. This is a dynamic power consumptions percentage and cell average power consumption for different time period updates. Now we are in the highest order of the massive MIMO, and now it's going to 16T 16R. From highest type we will go to the lower order of the massive MIMO. And still I think there is something happens here that because it changed. Yes, as we can see, from 16 it jumped to 32C 32R, 16T 32T 32R. Now it went down again. It's in the 16T 16R order. And new updates would be again 32T 32R. It should be jumped here, as we can see. And again jumped out to the highest order. And it's volatile among different values. Now it's going to jump to the 88R. So we should expect the lowest order here, as we can see in this figure. And let's see its impact on network slices. First of all, PRB usage has been done in the based approaches to be in an optimized value as much as possible. And here are the PRB usage per slice for a massive IoT, URLLC, and EMBB. Thank you for your attention.